Hello, mathematicians, and welcome to math lesson number 17. Okay, we're going to take what we've learned about measuring, we're going to put it together into something that we like to call perimeter. Okay, so perimeter is basically, it's the distance around the outside of an object. Okay, so when we're running laps in the gym, we are running around the perimeter of the gym. Okay, so if we measured the length of each wall of the gym and added them up, we would have the perimeter, and we'd know how far we've run. Let's say we have a little box that we want to wrap up. Knowing the perimeter, or the distance around the outside of the box, helps us know how much wrapping paper we'd need to wrap it up. Now, in your math book, they're going to draw a lot of shapes like this that are drawn in unit squares. So they're not telling you exactly how long each side is. We're just going to call it 1 unit. But it's really important when we're talking about perimeter and distance that we give some kind of a unit, because if I said I went 12 meters, but somebody else wrote down 12 millimeters, those are two very different distances, right? And so that would be very confusing. So we normally need to include some kind of a unit. A lot of these ones in your math book are going to be, each square is going to be 1 centimeter. So in between the two spots here will be 1 centimeter. If it doesn't say that, then you could just say it's going to be that many units. So perimeter, distance around. So I want you to imagine that you're going for a little walk. Okay, here's my good friend Kermie. He's going to walk around, okay, he's going to hop around the outside of this shape. And he needs to know how many hops is it going to take him. Okay, so we can count each one of these line segments. So I always like to mark where I've started so that I don't get confused and keep counting and or doing more laps than we really need to. Okay, so Kermie started here. He jumped once, twice, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the perimeter of this shape is 12 units. Okay? So really make sure you don't count the inside lines. Those ones don't matter. It's only the ones that you would walk along the length of as you're walking around the outside. Okay? Or you could measure the side, and we could say, oh, this side here is going to be 4. This side would be 1. This side, 3. This side, 1. This side, 1. And the last side, 2. And so then, in this case, our perimeter would be equal to 4 plus 2 plus 1 plus 1 plus 3 plus 1, right? So we've added up all the different sides. 4 plus 2, 6, 6 plus 1, 7, 7 plus 1, 8, 8 plus 3, 11, 11 plus 1, 12. Oh, look at that. Still 12, and remember we got to put units if we don't know exactly what units they're giving us. Okay, thanks for your help, Kermit. Okay, so if the distance, perimeter is the distance walking around, we could have some weird shapes, but still count or add the perimeter. Okay, what if Kermie had to walk around the outside of this one? Well, he'd definitely get his exercise. And he'd have to go in some weird directions. Ooh, getting in there might be tricky with his big feet. Okay, so he's hopped himself around the whole way. He started here. Okay, so again, we can just count the outside lines to figure out how far he went. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Okay, so in this case, the perimeter that he walked was 22 units of some kind. Okay, do you notice how I made the little ticks as I was working my way around? That way I could remember exactly which ones I'd already counted, so that I wouldn't count any one segment twice. And then I can go back and check and make sure that none of those inside lines have any ticks, because he didn't go inside this building, he only walked around the outside. Okay. So I could also measure using a ruler. All right, so this side of the box, that was 3 centimeters. This side of the box, let's make it 7 centimeters. Okay, and then the whiteboard marker rubs off with the ruler, so we're going to just do our best on the other sides. Okay, so we know that if that side's 3 centimeters, this side is going to be the same length. And if that side's 7 centimeters, this side's going to be 7 centimeters. But you could use a ruler to check all of those things, right? So same thing, if Kermie walked around the outside of this one, we'd want to know where he started so that he doesn't get mixed up. And the perimeter, okay, first he goes past a 7 centimeter side, then he walks past this 3 centimeter side, then he walks past another 7 centimeter side, and finally he goes past one more 3 centimeter side. Add those all up. Ooh, this is very fun. Okay, 7 plus 3, that's a 10 buddy, so we've got 10, and another 10, 10 plus 10, 20 centimeters. All right, luckily Kermie seems to be sitting down and having a bit of a rest, otherwise he'd have had to walk 20 more centimeters for us. Okay, now sometimes architects or gardeners or engineers or math textbooks, they might draw a model, a scale model of a shape. And they label the sides of the model with the real life lengths. So we can't use a ruler because it doesn't match the real life, right? But we can add the numbers and use the units that they've given us. So they're saying that this rectangle here has a side length of 6 meters and another side length of 3 meters. Well, I can't use a ruler because here's my meter stick, remember? Look how big it is. That's obviously not actually 6 meters or 3 meters. So I'm just going to have to use my smarts to figure out what the perimeter is. Now, they were sneaky on this rectangle, and they didn't give us these two sides. How would we know what they are? Well, that's easy, Miss Hughes. You're saying, oh, it's a rectangle, so these two sides have to be the same length. And these two sides have to be the same length. Otherwise, it's not a rectangle. It would be crooked. Okay, so now we know that the perimeter is the distance around. Okay, you can add a starting point if you want. So the perimeter is going to be 6 plus 3 plus 6 plus 3, which is the same thing as 9 plus 9, which would be, 18, and then we have to put their units in, right? So they're telling us it's meters. We're going to say it's meters, even though, obviously, it is not, right? Whatever they are modeling would have had a perimeter of 18 meters. All right, so let's take a look at this triangle version. Okay, so again, the perimeter is just the distance around, so we have a starting point. In this case, it's going to be 4, sorry, little froggy, plus 4, plus 4, which is the same thing as saying 12, and then it can't just be plain old 12, we've got to add the units. Ooh, they used km, which we haven't talked about yet. That's a kilometer, which is 1,000 meters. So a kilometer is 1,000 times longer than our happy little meter stick. It's a long ways. All right. Now, the last thing your math book might ask you is which of those has a greater or bigger perimeter? And this is where units matter, right? 18 is a bigger number than 12. So you might be inclined to say, ooh, the rectangle has a bigger perimeter than the triangle. However, a kilometer, even just 1 kilometer, is 1,000 times longer than 1 meter, so the kilometer would definitely win out, okay? So the triangle would be the biggest one, okay? So just be really careful when you're answering this question in your math book where it asks you to rate the different shapes by the size of their perimeter. Check which order they're asking you to do it in, and also look carefully at those units. They make a difference. Okay, so this week, in order to get all your math practicing in, if you have a green math book, you're going to do page 271 and 272. If you need any extra challenge, you can try page 273 to 275. Blue math book people, you're going to do page 114, 115, 116, and 117. You've got all your extra challenge built right in. Okay, take care. Keep up the good work. Happy mathing.